Hi, welcome to my channel Education for Aspirants. Today I am going to discuss the procedure to delete an element in AVL tree. The prerequisites to understand this deletion process are the deletion process in BST, the different rotations used in AVL tree, and to traverse the tree by using in-order procedure. Let's start the session with the concept of deletion in AVL tree. So you know that AVL tree is the extension of binary search tree, right? So that's why to delete a node in AVL tree, as per the rule of binary search tree, we will delete it. Then after deletion, we need to check the balance factor of each and every node inside the tree. If any node got imbalance inside the tree, then we need to make balance to that node. To make balance to that node, we need to follow some certain turning methods. So how you will apply the turning methods? What is the process you need to follow? We need to see the rules now. First, move towards the root from the deleted node and apply turning on the first imbalance node which is present in the ongoing path. Means after deletion, if one or more nodes are got imbalance, then what you need to do? First you move from the deleted node towards the root node. At the time of moving, which node you got the first imbalance node, you apply turning onto that node. Then always apply turning on the imbalance node along with two elements serially in its heavier side and which are present in the opposite side of the deleted node. This is the key point, just remember. In which side of the imbalance node the deleted node present, in its opposite side you will perform the rotation. You know that to make a rotation we require 3 nodes. So here along with the imbalance node you need to take 2 more nodes for the rotation. Now what is the third rule? Third rule is check the balance factor of the node which is the child of imbalance node and present in the opposite side of the deleted node. You have deleted this node. So after deletion of this node, the balance factor of this node will become -2, right? And this will become 0, this will become 0, this will become 0. Clear? Now what it is saying, after deletion of this node you need to decide in which side you need to apply turning. So the rule is in which side of the imbalance node the deleted node present, on its opposite side you will apply the rotation. Means the deletion node present in the left side of the imbalance node, that's why you will apply rotation in its right side. Clear? Then find the balance factor of the node which is the child node of imbalance node. So here what is the child node of imbalance node? This node is the child node of imbalance node, right? For example, this is A, this is B, this is C, this is D. B is the child node of imbalance node. Okay? So find the balance factor of this node, and this balance factor will guide you what type of rotation you will have. How it will guide? If the balance factor of this node equals to 1, it implies that it is heavier in its left side. If the balance factor is 0, it implies that that node is equally balanced in the left, into its left and right. But if the balance factor of B is -1, it implies that it is heavier in its right side. Clear? So these information you will get in that table. So here I have given left node deletion table and right node deletion table. 1, 0 and -1, these are the balance factor of this child node. Clear? And all the balance factors are associated with some turning method. So first find the balance factor of the child node, then with this balance factor go to the table and find what is the rotation associated with it. Then as per the rotation you apply the rotation on the imbalance node. I hope understood. These are the 3 rules. Now we will discuss this means deletion process with an example. Let's consider this AVL tree and we need to perform these 6 deletions: 12, 26, 25, 18, 35, 30. We will delete one by one. We will delete 12. 12 is a leaf node. Simply delete it. So I deleted the 12 now. Now after deletion of 12, find the balance factor of each and every node. Now you can observe here, after deletion of 12, the balance factor of 15 got imbalance, right? To balance it, you need to decide what type of rotation you can apply here. See, if you see to the figure, what is the imbalance node? 15. In which side of 15 you deleted? That is left side of 15. Means you perform the deletion in the left side of 15. Now in the opposite side of 12 means deleted node, you will perform the rotation, right? So in the opposite side of 15, what is the child node? Balance factor, that is 1. Then if it is 1, it implies that it is heavier in its left side. So see, go to the table, and what is the turning method associated with 1? That is right left. Clear? See here, we are performing right and left. I hope understood. So as per the right left turning, 18 will become the root and 20 will become the right side of root and 15 will become the left side of root, because 15 you will turn into the left side, right? Now see to the figure. I turn this right left rotation by making 18 as root, 20 as right side and 15 as left side, and the rest nodes I kept as it is. Now you calculate the balance factor. After rotation, you can see in this table all the nodes are balanced. So now we will delete 26. 26 is a parent node, right? So you know that if you delete a parent node with a single child, then after deletion the child will replace with the parent node, right? So see, in the final tree, 28 replaced in place of 26. Okay. Now find the balance factor of each and every node. So after deletion of 26, you can observe here the balance factor of all the nodes are within the range -1 to 1. Hence the tree is balanced tree. Now we will move to delete 25. 25 is a node with 2 child, right? So you know that if a node is having 2 child and you want to delete a node, then that deleted node will replace by its either in order predecessor or in order successor, right? So that's why first find the in order traversing order of this tree. So if you find in order traversing, then you will get here 15, 18, 20, 25, 30, 28, 29, 30, 35, right? So you want to delete 25, right? What is the in order predecessor of 25? That is 20. What is the in order successor of 25? That is 28. So after deletion of 25, either you will replace 20 or you can replace 28 inside the tree. Clear? Now see, I replaced 20, that is in order predecessor, in place of 25. Clear? And after replacing 20 in place of 25, find the balance factor of each and every node. You can observe here, after deletion of 25, the balance factor of all the nodes are within the range -1 to 1. Hence you can say that tree is a balanced tree. Now we will switch over to delete 18. So here first check what is 18. 18 is a node with a single child, right? Then after deletion of the node, that child node will replace in its place. Clear? So just replace it. Now I shifted the 15 in place of 18. Now after deletion of 18, find the balance factor of all the nodes. Now you can observe here in this figure, the after deletion of 18, the balance factor of 20 got imbalance. So what you need to do? You need to make balance it. And for balancing 20, you need to apply some turning method. So just decide what type of turning you can apply. Clear? So for finding this, first find in which side of 20 the deleted node was present, means 18 was present. That is left side, means you need to go for left node deletion table, right? Then next for turning, you go to the child node which is linked with the deleted node. What is the child node? That is 29. What is the balance factor of 29? That is -1. -1 means what? It is heavier in its right side, right? -1 means it is heavier in its right side. You can observe also in this figure, in the right side 3 nodes are there, 3 paths are there, okay? But in the left side only 1 node is there. Hence it is heavier in its right side. So you need to apply turning in the right side, okay? If you apply turning in the right side, serially take 3 nodes for making turning in the right side. Clear? So what type of turning it is? This is RR turning, right? This is RR turning. So if you want to confirm, go to the table and see here the balance factor of this middle node is -1. So come to the table and -1 balance factor is associated with RR turning, right? So now we confirm that we will apply RR turning, and as per the RR turning, see to the figure, I make 29 as root node, then 20 as left child and 30 as right child. Then the rest of the nodes you attached. So see here, so I kept 15 as left of 20, then already 20 present in the left, so I set 28 in the right of 20, so that 28 will become left of 29, right? I kept 35 as right of 30. So after rotation, you find the balance factor of all the nodes. Now you can check, after deletion of 18, the balance factor of all the nodes are within the range -1 to 1. Hence you can say that the tree is balanced tree. Now we will move to delete 35. 35 is a leaf node. So as per the rule, you can delete simply the leaf node. Okay. So I deleted the leaf node 35, and after deletion, this is the figure you can get. Okay. Then find the balance factor of all the node. Now you can observe here, the balance factor of all the nodes are within the range -1 to 1. Hence the tree is a balanced tree. Okay. So now we will move to delete 30. 30 is also a leaf node. I deleted 30 here, but after deletion 30, calculate the balance factor of each and every node. So after deletion 30, you can observe here, the balance factor of 29 got imbalance, that is 2. So now we need to apply turning on 29 to make it balance, right? So first you need to check in which side of 29 the deleted node was present. That is in the right side, means you will apply turning in its left side. Go to the left side of imbalance node, then find the balance factor of the child node of the imbalance node. So here the balance factor of the child node is 0, right? So if the balance factor is 0, as per the rule, go to the table and check what is the rotation associated with the balance factor. So the balance factor is 0, means that it is associated with left rotation. Clear? So apply left rotation here. For left rotation, these 3 nodes you required, right? These are the 3 nodes you required for the left rotation. See to the figure. In this figure, I made 20 as root node, 15 as the left child, and 29 is the right child. Then the rest node, that is 28 present in the right of 20, right? But already right of 20 is present 29. Right of 20 already 29 present. So what you need to do? You need to set 28 in the left of 29, so that it will become 28 will become in the right side of 20. Clear? Then after rotation, find the balance factor of each and every node. You can observe here, after deletion of 30 and after applying the rotation, the balance factor of all the nodes are within the range -1 to 1. Hence you can say the tree is a balanced tree. With this we have completed the deletion process. I discussed the deletion process in the AVL tree by considering different rotation methods. I hope you guys understood it clearly. Thank you.